Hi, welcome Algebra 1B students. In this video we will be talking about how to solve a quadratic equation by completing the square. Now, a quadratic equation is one where the highest power is 2, and so I have two examples here that I'm going to use to review the concepts that we've learned the past couple days. We learned how to solve a quadratic equation by factoring, and that would be a technique I can apply on the left side. Taking an x out, taking the greatest common factor here, I'll have x times x plus 5 as my factored form. And then using something called the zero product property, which says that if two things are multiplied and they equal 0, then either the first factor needs to be 0 or the second factor could be 0. So in the case we have here, we'll have x equals 0 and x plus 5 equals 0. Solving the second equation by subtracting 5, I'll get x equals negative 5. So in this case, we have x is 0 and negative 5. Now, the other technique we learned was the square root property, which only applies when you have a single x term. In this case, we will do inverse operations to isolate the x squared. We'll add the 9 to both sides and get 20. Let's go ahead and divide by the 2 to isolate the x squared. And this gives me x squared equals 10. To undo the squaring of the x, what we do is we square root both sides. And that's going to leave me just with the x on the left side. And then we have to remember that anytime you use the square root property, you have to have a plus or minus of the square root of 10. Alright, so here that's reviewing the two techniques we learned to solve quadratic equations, but you'll note that each technique has its limitations. They only work on certain quadratic equations. Namely, the factoring only works when you can factor the quadratic equation, and the square root property only works when you have a single x value. But the next technique, our completing the square technique, is nice because it can work on any quadratic equation. So we're going to do 3 examples. Let me move on and show you, at least give you some more motivation of why we need this technique. Here's a quadratic equation. If we try to morph this, if we try to solve by factoring, we're going to try to look for factors of negative 10 that add to 6. Let's see, factors of negative 10 are negative 5 and 2, negative 2 and 5, negative 10 and 1, and negative 1 and 10. None of those factors add to 6, so this is not a factorable quadratic, which means my morphing or my factoring technique does not apply. And once again, I can't use the square root property because of I've got two x values here, so I can't use the technique. Remember, I can only use the square root property when I had a single x term. So here are the steps to complete the square. You'll write the quadratic in standard form, which standard form is written with the x squared first, ax squared plus bx plus your c. That's standard form. And then since it's an equation, we'll have to have it set equal to 0. We'll add and subtract the c from both sides, so we'll move that c to the right side. We'll divide everything by a. We'll find a new c by taking half of b and squaring it. We'll add that new c to both sides, and then we'll factor, sometimes called a mini-marf. And then after we factor, we can use the square root property. Pause this video as needed, but let's look at the first example. Okay, so here we have a quadratic equation where you cannot factor it. There are no factors of 2 that add to 6. So I'm going to note here the a is equal to 1, the b is equal to 6, and the c is equal to 2. So what we're going to first do is make room for our new c. So I'm going to rewrite this quadratic equation by moving the 2 to the right side. I'm just going to subtract 2 from both sides, and that'll give me negative 2 over here. Now what we're going to be doing is we're going to be adding a new c to the left side to make it a factorable quadratic. But to do that, we'll pay for it by adding that c to the right side as well. So here's the formula you have to memorize. To find our new c, we're going to take half of b and square it. So that's half the 6. We'll take half of 6 and we'll square that value. So half of 6 is 3, and then 3 squared is 9. So 9 is the value that I'll be adding to both sides. Right here, I'll put a 9 here, and then to pay for that, I also have to add a 9 to the right side. Now, the left side is now factorable. We'll be searching for factors of c, factors of 9, that add to 6. That's 3 and 3. But if you complete the square correctly, then it should be factorable every time. Let's see. So it's x plus 3 times x plus 3, and we want to write that as x plus 3 squared. The right-hand side we're gonna clean up. Negative 2 and 9 makes 7. And so now what you have is a quadratic equation where I want to use the square root property. I have a single term that's squared, so I will square root both sides, which will undo the squares at the square and the square root. This leaves me with x plus 3. Let's not forget the plus or minus in front of the radical 7. And then the final step would be to subtract 3 from both sides. So moving the 3 over, it's going to be negative 3 plus or minus the square root of 7. Alright, that's my answer. Let's do another example. Here we have a situation where I have to divide everything by 2. And let's go back. You wrote down that you have to divide everything by a. A is the number in front of the x squared term. So here we have a is equal to 2, b is equal to 24, and c is equal to negative 36. And we cannot complete the square if a is not equal to 1. In other words, a has to be equal to 1 to complete the square. In the previous example, a was equal to 1, so we didn't need to do that step. But here we have a situation where we will now divide by 2 to get a equal to 1. And to do that, we have to divide every single term by that 2. So what we'll have here is, let's see, we'll have 1x squared plus 12x minus 18 equal to 0. And I'll go through the same process now that we just did on example 1. We're going to move that 18, the negative 18 over, to make room for a new c. Let's see. So if I move the 18 over, I'll add it to both sides. And then I've got to make room for a brand new c that I'll find by my formula. Let's see. The new c is found by taking half of b. In this case, it's 12 now. B is the term in front of the x. So let's see, 12 divided by 2 squared is the formula. Half of b squared. Half of 12 is 6, and 6 squared is 36. That is the number that I'll be adding to both sides. So I've got a 36 here, and I've got a 36 over here. Now, the left side is a factorable trinomial. It's looking for factors of 36 that add to 12. And it should be no surprise here that these two numbers are, let's see, 6 and 6. That's how we set it up. So I'm going to write this as x plus 6 times itself. So I'll write that as x plus 6 squared. And then the right hand side, I'll clean this up. 18 and 36 make 54. And now I have an equation I can solve with the square root property. Square rooting both sides, the left hand side, the square will cancel. I'll have x plus 6, and then I'll have plus or minus the square root of 54. The final step is to get x by itself by taking away the 6. So here I have I have x equals -6 plus or minus radical 54. The only thing left to do is to simplify the radical, and I will do that by finding factors of -54 that are perfect squares. Let's see, I believe 9 goes into 54, so let's see, that's going to be square root of 9 times the square root of 6. And I do that now because now I can take the square root of 9 and it just clean things up a little bit. So I'll have -6 plus or minus 3 square root of 6. And that is the answer that we want to look for, the most simplified answer. Okay, one more example. If you notice here, we do have an a not equal to 1, so we need to clean things up. We need to divide by the 3. Before I do that, I'll subtract the 1 to combine like terms. So 3x squared plus 12x is the same as, let's see, if I subtract 1 from both sides, take away 1, I'll get the same as 15. Seeing that all these numbers are now multiples of 3, I will now divide by 3 so that the leading coefficient is equal to 1. And that's if it's not equal to 1, then you can't complete the square. But what I have now is as the coefficient of 1 in front of the x squared term. 12 over 3 is your 4x. And then 15 over 3 is 5. So now what we want to do is make room for our new c. So I'm going to rewrite this equation, and notice that c is already moved over there, so it's just a matter now of adding a new number to the left and adding a new number to the right. Let's see. This is a formula. C is equal to half of 4 squared. Let's see, half of 4 is 2, and then 2 squared is 4. So this is a number that I'll have to add to both sides, 4 and 4. Once this step is complete, I will recognize the left side is a trinomial that's factorable. I need to find factors of 4 that add to 2. Factors of 4 that add to 2 are 2 and 2, so it's x plus 2 squared. And cleaning up the right-hand side, 5 plus 4 is 9. Alright, now we're ready to use the square root property, which if I square root the left-hand side, it cancels out the square. And if I square root the right-hand side, the square root of 9 is equal to 3. So that's plus or minus 3. The final step now here is to subtract the 2. So the answer is plus or minus 3 minus 2. Now what this means is I get 2 answers. One answer will be, let's see, I can either have a plus 3 minus 2, which is 1, or I could have a negative 3 minus 2, which will give us negative 5. So once again, 2 answers again. No surprise though, since we have a quadratic equation. Every single one had 2 answers. We had 2 answers here. We had 2 answers on the first example, and even the technique of factoring and using the square root property resulted in 2 answers. And this is our third technique. It's called completing a square, and it works for all quadratic equations.